Hi, everyone. So yesterday we were working on classifying different kinds of triangles. And when we were working on one of the classifications, we were talking about the angle measures that make up triangles. And remember, we were talking about the obtuse angles, which we learned last year was any angle that's bigger than 90 degrees, rather. And we have acute angles, which are angles that are smaller than 90 degrees. And then we have right angles, which are equal to 90 degrees. And we were playing around with that term degrees a lot yesterday. And what we're going to do today is we're going to backtrack a little bit to build up some more angles vocabulary and some more understanding about the properties of angles as they're going to apply to triangles and other shapes that you and I are going to be talking about in the next unit. So as we go into our next lesson here, let's go over some vocabulary words, which I have up on your screen right now. And one of those words is a line, and a line goes on forever and ever and ever. It really never ends. And it's written as line XY, okay? Those two letters might be different depending on what points are actually on the line. But the symbol with the arrows up top is always going to represent a line. Then we have a line segment. And a line segment does not go on forever. It simply comes to a stop at these 2 points. So they become endpoints. And it's written as segment XY. So again, those two letters might be different depending on what is actually on the line segment. But notice that the symbol has changed here. Okay, there's no arrows on the end. The arrows on the end of the line symbol mean that that line technically keeps going beyond those 2 points. And an angle is where two lines or rays, when we get into talking about rays, they come together and meet, and that intersection is measured in degrees. So if we look at the capital L right here that I've put up on the screen, that's not a typo, it's actually there on purpose. It's where two line segments are meeting, correct? We have the vertical one here and the horizontal one here, and we can measure the distance between these two lines right here, this angle, in degrees. Okay, so what we're going to do right now is we're going to practice a little bit of naming lines, line segments, and angles, just so that we're more familiar with these terms when they start showing up later on in our study of geometry. So I'm going to click over to my document camera here, and we'll take a look at my screen right now. And the first thing I've drawn up here is a line. And I know that it's a line because it has arrows on the end, it keeps going, and it's extended beyond the 2 points that are here, okay? So in this particular drawing, I have line AB, and I know that it's line AB because it's a line, okay? So I'm going to draw the arrows, and then I have points A and B are on this line. Down here, this is a line segment. Notice that it starts and stops at these 2 points, these endpoints here. So this is segment CD. Now notice I didn't put arrows on my little line above here because this is a line segment and not an actual line. Now our math book in Think Central gives us 2 ways of writing and drawing angles. So one of the ways it will show angles to us is by simply creating the angle arc and putting a lowercase letter inside here. Okay, so this is asking us to find angle F. Okay, and I'm naming that angle simply off of its label there. And I use this little bent over L-shaped symbol to represent the term angle. If I want to represent the measure of a certain angle, so I might ask you, what is the measure of angle F? I'm going to write M for measure, the bent over L for angle, and then the F, or whatever angle it may be, okay? So we are really just focusing on naming right now, so we're only focusing on that angle piece. This angle over here, though, I drew it out a little different. It doesn't have an angle on the inside, like over here. This angle has 3 letters, and it's measured on these points here. So what I have to do is I have to look at where is the actual angle point, okay? And that angle point is right here at point Q. What I can do is then take the endpoint go to the middle point, and then to the other endpoint. So this angle's name is angle PQR. And if I were to trace this in order, I start at the point P, I go to Q, and then I go to R. Now, could I also say that this is angle RQP? And I'll move my camera down so you guys can see that. So is this angle RQP? Well, if I start at angle R and I go to angle Q and then to angle P, I trace on the exact same line. So that's all good. Let's try this one. Could I call this angle QPR? And if I can, then I shouldn't have any green showing when I trace this line, and I shouldn't have invented any lines when I trace it. So what this says is I start at angle Q, I go to P, and then down to R. Well, I traced one line, but to get to R, I had to pass through point P. So I created a line over here, and we can see that this green line is still showing. So therefore, this cannot be angle QPR. Remember, the point that's at the angle always goes in the middle of your naming. Notice that the Q is always in the middle of my naming. All right, so we've done those problems together. Let's take a look at a couple samples now together and see if we can name these figures that I've drawn up here. So the first question we have to ask is, GH, is this a line or a line segment? And the answer to that is, it's a line segment, right? There's no continuation beyond G or H. So I have to express this as segment GH. This next example, is this a line or a line segment? And the answer to that is, it's a line. So I have to write the line symbol. And then I have to name this line. So I'm going to name it JK, because those are the points that are on the line. We're not just kidding about anything. And finally, down here, we have angles. The name of this angle is the name of the letter on the inside. So this is angle T. Over here, we're looking for this angle. I should have drawn that piece in there because there is an angle over here, but there's no letter over here. So if I wanted to name this red angle right now, I have to name it based on the 3 letters. There are 2 correct answers for this angle. Go ahead and try to figure out those 2 correct answers. And you should have gotten that I start at W, go to X, and then to Y. Or I could have done it backwards and started at Y, gone over to X, and then to W. I cannot go in any other direction for this problem. Okay, so we've had all that fun now on naming angles and naming lines, and we're going to do some work now with angles on lines. That's the whole point of today's lesson. So in this particular example, we have to remember that there is a certain amount of degrees on a line. So the math law for us is that on every line, every straight line, there's 180 degrees. Now, if there's 2 angles on a line, and we know how many degrees are in one of those angles, we can figure out the missing measurement. So the magic number we have to remember all day today is 180 degrees. Okay, 180 is going to be our magic number that's going to really be helpful to us. So let's backtrack over to this example now. Now, I have line AB here, and sometimes your math book will come out and say, oh yes, AB is a line, and they'll give you a little note like that. And I have this little segment over here that meets at a right angle, and I have to figure out the measure of angle A. So I have to find what's missing over here. So my job is to figure out and use the rule of 180 because it's a point or an angle on a line. So I have to figure out if there's 180 degrees here on this entire straight line, and right here, there's a right angle. So how many degrees are in a right angle, right? We see the right angle box right here. If I know how many degrees are in a right angle, this will make my problem a little bit easier because I have a hole, I can take away the part and figure out the other part. So in a right angle, there are 90 degrees, and then I'll subtract, and I'll find that angle A, what's left over, there's only 90 degrees. So this is 90 degrees here, so the measure of angle A equals 90 degrees. Now this next one down here is rather interesting because I didn't write any numbers in the problem, and I didn't give you a right angle box. So you don't automatically know that one of these is 90 degrees or not. But it's always important to look below the problem as well to see what key information you can fill in on the diagram. So the measure of angle B is 140 degrees. So here's 140 degrees. Now I have to figure out the measure of angle C. Now I can remember to use the rule of 180 because this is a straight line right here. So again, I can do some subtraction. And I know that if there's 180 degrees on a line, angle B is part of that. It's 140 degrees. When I subtract, I'm going to get the part that's left over. So I'm going to subtract and find that the measure of angle C is just 40 degrees. All right, so we got through those couple examples. Now let's do a couple more challenging ones. All right, so right here, I gave us that we have line EF. And it looks like I have two segments here creating 3 angles. And what's important here is there's information down here that's going to be helpful for me solving this problem. But I see this other piece of information right here. And I always love working with that little box because that box is our right angle symbol. So I look for that box and I say, I have 90 degrees. Let's write that in there immediately. So I know that I have 90 degrees. Now let's look at the other information that I've been given. And I've learned that the measure of angle A is 50 degrees. So what I'm going to do now is I'm going to fill in the measure of angle A is 50 degrees. So really, this problem is asking me to take the information I already know and then figure out this missing piece right here, this missing angle B. Well, this is a multi-step problem because I know I have a right angle and I know I have 50 degrees in angle A. How many degrees do I have altogether between these two spots? Well, I can add 90 plus 50 to get 140 degrees. And then I can do 180 minus 140 and get 40 degrees for angle B. Now, there's a very good way to check to make sure I have the right answer. The way I can check my work is by remembering that the angles that all meet on this line at one particular point have to equal 180 degrees. So if I wanted to check my work, I need to add 50 plus 40 plus 90. Well, 50 plus 40 is 90. 90 plus 90 is 180. And remember what we said on this last page over here, that 180 is the magic number. So if this all adds up to 180, we're in good shape. Our final example today, a little bit more challenging. Now I've given us this really crazy diagram here, all these lines coming together to meet. And I have angle BED and angle AEC are both right angles. So I'm going to draw this out in green and in red. So I know that angle BED, angle BED, so as I trace that, I'm being told that this is a 90-degree angle. And angle AEC is a 90-degree angle as well. So there's some sharing going on between these two angles. This BEC section right here is shared between the two angles. Now, the directions tell me over here, if angle CED is 55 degrees, find the measure of angle AEB. Okay, well, I'm going to have to use some rules of angles to help me figure this out. Now, I might be using more rules of right angles here. So angle CED, that's this piece right here, is 55 degrees. And you know what? That doesn't really help me. And the reason why it doesn't help me is because, well, it could actually help me, but it'll help me figure out what this piece is over here. And I'm not looking for that piece. I'm looking for angle AEB. I'm looking for this piece right here. So what I can do is figure out how much is left in BEC. And I know that a right angle has a certain amount of degrees, and that's 90 degrees. So if I start with my 90 degrees, and I take away the 55, I have 35 degrees left in here. Well, now I know that angle AEC is a right angle, and part of it is 35 degrees, right? So I can just do some subtraction work, and guess what? The answer should be 55. We're just going to check it anyway. And look at that. The answer is 55 degrees. Now, in this problem, I really did not have to use the rules for angles on a line. This one was really testing my ability to remember how many degrees are in a right angle, and can I apply that property in a complex problem? All right, so your problems today are going to be asking you to find missing angles on lines. If you have any questions, please reach out to us, and have a great time working on your angles on lines. Thanks for joining me.